Welcome back, students. Let us see the same chapter number 4, and it is video number 30. In this chapter, lots of things we have seen. From that, we have to recall few equations. First of all, in this video, we will see the circular loop as a magnetic dipole. Right? There is a new word, magnetic dipole, but dipole is old one. Right? What is dipole? That we have seen. Got this action? Two equal and opposite charges are separated by some definite distance that is known as dipole. Clear? So, instead of that electric dipole, we have a word magnetic dipole. Clear? Okay. Now, there is one more equation that we have to remember for a circular loop. If you will go to that previous assignment, you have already completed that work. The question was like this. Obtain the equation of magnetic field for a current carrying circular loop at a point on axis by using Biot-Savart law. Okay, so in that theory, which equation we have obtained? We have obtained the equation of magnetic field. What was that equation? B is equal to mu 0 I capital R square upon 2 in bracket x square plus R square raised to 3 by 2. Give it. Equation number 1. Oh sir, which is the theory? We are not getting idea. Okay? So, let us see. I think so. You might have seen this type of figure. Got it? So, this is a circular loop carrying electric current, and this circular loop having radius r. So, that r is here. What is x? X is the distance from the center. So here there is x, and at that distance we have taken point P, and at this point what is the magnetic field? And equation is here. Okay, check it out in your notebook. It is already there. Clear? Now what to do? Let us see. Okay, where was the point? It was on the axis. Got it? Now, let us take first case. Which case? If x means the point P is very far from the circular loop. If x is very greater than capital R. So in this situation, put R is equal to 0 in that bracket term. Means this R is equal to 0, you have to put here only. Okay? Then we are getting equation of B like this. That is B is equal to mu 0 I R square as it is upon 2. Right? X square only. X square, we have placed R value 0. So this term becomes 0. So what will remain? Only 3 by 2. So 2 will cancel out. And finally, we are having equation of magnetic field on axis is equal to mu 0 I R square upon 2x cube. Clear? Simple thing is that we have used equation of magnetic field for a circular loop on axis. Got it? Then we have taken one condition, x is very greater than r. So we have taken r is equal to 0, and that r is equal to 0 we have to place in equation number 1. Then we are getting the equation b is equal to mu 0 I r square. Clear? Now what to do? For this equation you have to multiply and divide by pi. Why? We will see later on. Okay? Now what to do? Multiply by pi and divide by pi. So we are getting equation b is equal to mu 0 I as it is, mu 0 I as it is. Here let us multiply by pi, so it is pi r square upon here 2 pi multiply by x cube. Got it? So what is pi r square? Where pi r square is nothing but area of a circular loop. So it is the area of circular loop. Okay? Then instead of this put a, so we will have equation of b is equal to mu 0 IA upon 2 pi x cube. What is IA? In last video only we have seen IA. It is a scalar product of electric current and area of the rectangle coil. Right? So in short, electric current multiplied by area is nothing but M. What is M? M is known as magnetic moment. Okay, this magnetic moment having symbol M. But after this video, we will see the different symbol. Instead of M, they have used mu also. Right? Means if you will see M or mu is nothing but magnetic moment. So put IA. Instead of IA, you have to take M. So we will have equation B is equal to mu 0 Im upon 2 pi x cube. Is there any mistake? Yes, exactly. So we have placed the value of I. So what will remain? Let us see. Instead of IA, you have to put M. So it is M. Got it? But generally we are taking mu 0 upon 4 pi. So here 2 is there. Right? So instead of 2, we have to bring 4. So for this you have to multiply and divide by this equation by 2. So we will have the equation B is equal to mu 0 multiply by 2. So here there will be 2m upon 2 to the 4 pi multiply by x cube. Give it equation number 2. Simple thing is that. Got it? Let us do quick revision of this. B, it is the equation of circular loop on axis. Take a condition, x is very greater than r. So put r is equal to 0 in that bracket term only, mind well. Don't put here r is equal to 0, otherwise the term becomes 0. Okay? So in bracket term only you have to put r is equal to 0. These are the simple steps. These are the mathematical steps that you have to remember. For an example, after this, r is equal to 0 we have placed. After this, what we have to do? Multiply and divide by pi. So we are getting the equation. What is pi r square? It is area of circular loop. So pi r square instead of pi r square A. What is Ia? Is nothing but magnetic moment M or mu, but just now we will remember only M. What is M? M is the magnetic moment. Then after multiply and divide by 2. Why? Because here generally we are taking the equation mu 0 upon 4 pi bar. Why? Because it is a constant. Got it? So this is the equation mu 0 upon 4 pi multiply by and divide by 2. So here 2 to the 4 and 2 as it is. Got it? Look for a few seconds. Okay? Which was the last equation? Let us say. For what we are obtaining? For an axis. So, for an axis, we have obtained equation that is B is equal to mu 0 upon 4 pi multiply by 2m upon x cube. Okay? This equation is very similar to the equation of dipole for electric field. So this equation is very similar to the equation. Which equation? That is E is equal to, instead of mu 0 upon 4 pi, we have used a constant that is 4 pi epsilon 0. Okay? 2. As it is, what is M? M is the thing but magnetic moment. But whenever we are looking for electric field, then there is a electric dipole moment. And electric dipole moment was symbolized as small p upon x cube as it is. Clear? Got it? Okay. Similarly, if we will see the equation for equator, then let us do some reverse. Okay? What was the equation for electric field for equator? Let us see. It was 1 upon 4 pi epsilon 0 multiplied by, here instead of 2p there was only p upon x cube. From this, if you want to write equation of magnetic field for a circular loop carrying electric current on equator, then the equation becomes, instead of E, we have to place B is equal to 4 pi as it is. Instead of 1 upon epsilon 0, you have to place mu 0 multiply by, instead of electric dipole moment P, you have to put magnetic dipole moment M. That is M upon X is the distance. So keep as it is. Got it? It is there on page number 160 and 161 of our physics textbook. Clear? Now here you have to remember few things. Which things are there? Let us see. So there is a little bit comparison between electrostatics and magnetism. let us see. Here, let us take first constant. In electrostatics, we have used as a constant, it was 1 upon 4 pi epsilon 0. Okay, but when there is a matter of magnetism, we have used, instead of 1 upon 4 pi epsilon 0, we have used mu 0 upon 4 pi. Okay, let us see. As a symbol, in electrostatics, there is electric field, and electric field was symbolized as E, but in magnetism, there is a magnetic field, and that magnetic field is symbolized as B. Okay, then let us take its dipole. When there is electrostatics, dipole having electric dipole moment. So that electric dipole moment is symbolized as P. What was its equation? P is equal to 2A multiplied by Q. What is Q? Here, Q is nothing but it is a charge. But the same equation, if we want to write for magnetism, then instead of dipole, here there is magnetic dipole moment. So instead of P, we have to take M is equal to, here what was 2A? 2A was the distance, and here you have to take a distance, that is 2L multiplied by Q. Instead of Q, you have to take P. What is P? It is new, right? It is not there in our textbook. This thing I took from that reference book. What is P? P is nothing but M by L. What is M? Magnetic moment per unit length, and it is known as pole strength. Got it? Okay, detail will be there in our assignment. Then, just now we have seen for axis. For axis, what was the equation of electric field? E is equal to 1 upon 4 pi epsilon 0 multiplied by 2p upon x cube. And the same equation for magnetic field, B is equal to, now see, just we are changing the symbols. Instead of E, B, 1 upon 4 pi as it is. So 1 upon 4 pi, instead of 1 upon epsilon 0, we are writing mu 0. Instead of 2p, we are writing 2m upon x cube. Got it? So by this way, we will have the equation of electric field, equation in electrostatics. By changing few symbol, we will have the equation of that magnetism. Okay? Same way, let us see for an axis. Now see equator. For an equator, E is equal to 1 upon 4 pi epsilon 0 multiplied by P upon x cube. Now here, which equation will come? What will come? Let us see. Instead of E, B 1 upon 4 pi epsilon 0, 1 upon 4 pi epsilon 0, but what is 1 upon epsilon 0? Is nothing but mu 0, so there will be a mu 0. Instead of P, magnetic moment M upon x cube. Okay, equations are there in our textbook on page number 160 and 161. Have a look for a few seconds. Got it? There are a few more equations. Again, I am telling you, it is not there in our textbook, but you will get these things in our assignment. Okay? In electrostatics, we have obtained equation of torque. Which was the equation? Tau is equal to, याद करो, what is tau? Tau is equal to P cross E. And in magnetism, we have seen tau is equal to M cross B. Just see, P electric dipole moment, M magnetic dipole moment, E electric field, B magnetic field. Got it? Then what about force? That is, force F is equal to Q multiplied by E. So it is electric force, but when we will go for magnetism, then it is a magnetic force instead of Q. What? P. What is P? P is nothing but pole strength. Got it? Instead of E, there will be B. Okay? Now, one more equation of potential energy. That is, U is equal to minus P dot E. Okay? This thing we have obtained in chapter number 1 in our school. Okay? Then the potential energy, this is for electrostatics, so it is electric potential energy. But in magnetism, there is a magnetic potential energy and it is given by U is equal to minus, as it is. What is P? P is electric dipole moment, but here magnetic dipole moment is M, that is M dot, instead of E, let us take magnetic field B. Okay, so it is end of our videos. Okay, in this video what we have learned, we have seen just the transformation of equations from electric field to magnetic field, electrostatic to magnetism. Okay, but one thing we have to remember, in electrostatic we have seen two equal and opposite charges are there. They are separated by some definite distance, it forms electric dipole. There was one term also, point dipole, means distance becomes 0. So two charges coincide with each other, it forms a point dipole. But this type of point dipole, this type of monodipole do not exist in magnetism, mind well. Means electric dipole exists in electrostatic. Why? Because there are two equal and opposite charges. But in magnetism, for a current carrying circular loop, point dipole, or you can say that monodipole in magnetism do not exist. Okay? Have a look, enjoy, stay home and be safe. Thank you.